Hi everybody. Yeah, in my last class, you have seen indefinite integrals, some important formulae, substitution methods, some problems. So in this video, you can see the second important concept of indefinite integrals, that is integration by parts. By looking at this video, you can understand when two function comes, how to integrate, what are the types of integration by parts, and in this you can observe one special case also, which is an important a problem or model both for board exams and objective as well. Let us go through the theorem first. Integration by parts. Integral, when two functions come in one integral, then it is first function. First of all, you categorize this as first function and this as second function. You need to remember this as first function into. See, after looking at this, u integral v dx minus integral d by dx of u, again integral v dx and whole dx is quite difficult to understand, is quite confusing. If you read that in another manner, then it is easy to remember. So I call this first function. So this total thing can be read like this: first function into integral of second function. I don't write dx here because every integral requires dx. So in the second function itself, dx is there, you have to suppose. Okay. So I write this as first function into integral second function minus integral of derivative of first function. D of 1 means derivative of first function into integral of second function, and for this integral 1 dx. For here 1 dx of course, and for the total thing dx. So how to read this? First function into integral of second function minus integral of derivative of first function into integral second function whole dx. If you try this, if you say this repeatedly for 10 times, then you can remember this, and it is compulsory in order to do problems on integration by parts. It is a must to say this: first function into integral of second function minus a big integral of derivative of first function into integral of second function whole dx. You have to read in this way. Practice. Okay, after saying this for 10 times or 20 times, if you are confident that I remember this formula, then go through problems directly. After this, let us prove this. First of all, how to prove this? So here, if some integral of some function is there, and if I integrate this function, if I got some other function, say capital F of x, what is the meaning of this? We know integral as antiderivative. Okay, so if we differentiate this, I should get d by dx of this one is equal to f of x. Is it not? Derivative of this one is this one. So derivative of this total thing must be this one. So if I can prove that, that is enough. So I take derivative of this one, d by dx of the complete right hand side integral u v dx minus integral d by dx of u into integral v dx whole dx. What is the meaning of d by dx is integral is the antiderivative of antiderivative means integral is antiderivative. Antiderivative means d by dx of integral of some function means it is a function itself, because we are seeing integral as antiderivative. Anti means reciprocal, not exactly reciprocal, they cancel each other, anti. So whenever d by dx and integral come with product, we can cancel them and can write a function itself. So you remember that one. Now see this as d by dx of a total function. Now I have to differentiate this part and this total part. If you observe this, d by dx of this thing, I'll write d by dx of u is one function, integral v dx is another function, minus d by dx of this total function, d by dx of u into integral v dx, okay, and for this total thing dx. If two functions are here and if you are to differentiate, we use uv formula, u into dy by dx of v plus v into d by dx of u. So I use the same formula, first function into derivative of second function. Just derivative and integral are both anti, so I can cancel them. I can write directly v plus second function into means integral v dx into d by dx of u, so du by dx. This part is over, minus this integral is for the total function, and this derivative is for the total function. So here also derivative and integral both are anti. We can directly cancel and write du by dx into integral v dx. So these two are same with opposite signs. So we are left with uv, proved. Therefore, if d by dx of this total thing is uv, then integral of this must be the total thing, no? According to the definition of integral. So proved. This is the proof. Now we can see one example. Integral x into tan inverse x dx. Here the problem is which function is to be taken as first function and second function. Generally, in 99% of the cases, we will follow Euler rule. I stands for inverse functions and L stands for logarithmic function, A stands for algebraic functions, T for trigonometric, and E for exponential functions. We have to maintain that order from top to bottom. So when two functions occur under one integral, you identify the functions. Okay, according to this order, you give the function category. Is it first function and this is second function, like that. If you look at this, what is x? Algebraic. What is tan inverse? Inverse trigonometric. So which should be given priority, top priority? Inverse. I is inverse. In the topmost place, inverse is there. So among these two, inverse must be given priority and must be taken as first function. This is first function. And your x is algebraic. Algebraic is after inverse only, down only. So this is your second function. Our objective is the function which we are taking first and second, whichever is second function, that should be easily integrable, because in our formula first function into integral of second function is coming. When two functions are there to integrate, what is the formula? First function into integral of second function. So whichever we take second function, that should be easily integrable. We should have an integration formula, or it should be easily integrable. Okay, in that way, if you observe, by observation, mathematicians have given this formula. In almost all the problems, if we take this form, we will get answers. questions get solved. Very minute problems, very less number of problems will be there where we have to deviate from this islet. So those are negligible. Okay, when situation comes, we can go through those problems also. But now, majority of the problems we follow islet rule, right? So if I take this as u and this as v, what you remember when first function and second function are known, I'll write formula first. First function into integral of second function minus integral of derivative of first function into integral of second function, and for this total thing dx. That is the formula. So in the starting stages, when you are about to learn the problems, you write the formula first and substitute. After getting thorough in solving these type of problems, then no need of using formula, directly you can do problems. So here, what is there in the place of first function tan inverse x? I write tan inverse x integral, second function is x. And remember, I said whenever you write integral, that integral requires dx. While writing function, you mention dx also. Minus integral. You have to differentiate first function. What is first function here? Tan inverse x. So tell me the differentiation of tan inverse x. 1 by 1 plus x square. That is the differentiation, derivative of first function. Okay. So derivative of tan inverse x, derivative of first function is tan inverse x, means 1 by 1 plus x square, into integral of second function. Your integral of second function is integral x dx, and to this whole dx. So you can remember here integral x dx, here integral x dx will be repeated. Tan inverse x into integral x means x square by 2 minus integral of, already we differentiated this, and integral of x is x square by 2 into dx. If we can integrate this, it's enough, because already this got integrated, and if we can integrate this, we'll get the answer. So let us integrate this. I am wrapping this part. There is nothing to do with this. X square by 2 into tan inverse x minus, I take this 1 by 2 common, I put it outside. We have x square by 1 plus x square into dx. Right? Now, see how to write that. Simply you think and see how to integrate that one. Directly we don't have any formula. And if I write 1 minus 1 by 1 plus x square, think whether these two are same or not. After doing LCM, 1 plus x square minus 1 plus 1 minus 1 cancel, and we are going to get this one only. Yes, this and this are same. So this is integrable, this is integrable. We have direct formula, integrable in the sense we can directly say its answer. X square by 2 into tan inverse x minus half of integral 1 dx is x minus integral 1 by 1 plus x square is tan inverse x. And for all these integrals, we require one constant. So x square by 2 into tan inverse x minus x by 2 minus of minus plus half tan inverse x plus c. I think you can stop it here. This is the final answer. We can do one more question. Basing on the same concept, you can practice these questions afterwards. integral x square sin inverse x dx, integral x square tan inverse x, integral x secant inverse x. Okay, you can practice these problems later. Now we'll go to the other model. The problem which we did can be considered as type 1. Now see, in this integration by parts only, we have type 2 also. In this type 2, you have to consider 1 as a second function. You have to consider 1 as a function first of all. Okay. Under what type of questions one should be considered as second function means, if you take integral ln x, okay, like integral sin inverse x, when logarithmic functions occur singly or inverse trigonometric functions occur singly, like only sin inverse x or only ln x, ln x plus b, sin inverse x plus b, like that occurs, we have to consider another function, that is 1. You have to consider 1 as second function. So in this case you have to take 1. In this case also you have to take 1 and follow. You take this function as first function. You have to take this function as first function and this as second function. Here in this case you have to take this as first function and this 1 as second function. Remember, when logarithmic function, when they occur singly, or inverse trigonometric functions, when they occur only single term, single function occurs, you have to consider 1 as second function and use by parts. These questions come under type 2. Now see how to solve this first function into, I think there is no need for me to write formula, because by this time you should be aware with the formula. You should have the formula in your mind. From that mind, let us retrieve this. First function into integral of 1 dx. Integral of 1 means dx. Integral of 1 dx is x. So first function into integral of second function. The second function is 1. Integral 1 dx means x, minus integral of derivative of log x 1 by x into integral of 1 dx. You remember already integral of first function, we have integral of second function, we wrote it here. So integral of second function comes again here, dx. First function integral of second function minus integral of derivative of first function into integral of second function, dx. These two cancel. So I can write this as x ln x minus integral of dx is x plus c. This is the answer here. And when you take this question, your first function is sin inverse x into integral of 1 dx means x minus integral of derivative of sin inverse x is 1 by root over 1 minus x square into 1 dx. Integral 1 dx is x into dx. So whichever function comes here, that is going to be repeated here. Remember. Now x sin inverse x minus, here x by root over 1 minus x square dx is there. Directly we don't have any formula for this. In integration by substitution, I said one formula. By looking at the question, you have to remember the appropriate formula which is useful here. you imagine, you think whether this formula is there or not for us. What is integral f dash x by root over f of x dx? So if you have gone through formulas well, you can immediately say it is 2 root f of x plus c. This is the formula. Is this really like formula? If your f of x part is 1 minus x square, what is the derivative of 1 minus x square? Its derivative must lie in numerator. 1 minus x square if is f of x, its derivative is minus 2x. But do we have minus 2x there? No. So let us write it is minus 2x. So already I took minus here, I have to suppose, so keep plus here. I multiplied by 2, you suppose, so I have to divide this. So in order to get f dash x there, whatever is required, you write that one. But immediately you have to divide by 2. I multiplied by 2 means I have to divide by 2. I wrote here minus, so there is no need to write minus once again here. If I keep plus, it is enough. Without loss of generality to the given problem, to the above step. No loss of generality here, both are same. Now this is like directly like f dash x by root f of x. For that we have formula. Now I can write its answer. This won't change x sine inverse x. There's nothing to do to this. Already integration, differentiation, everything is over. Only here we take first function into integral of second function, integral is also over. So no symbol of d by dx or integration here. So here nothing to do. This will carry on as we go until answer, that will carry on like that only. So I write x sine inverse x here, x sine inverse x plus half into, I made it this formula, for that answer is 2 root. So 2 root f of x is 1 minus x square plus c. These two cancel, and this is your answer. I hope you understood. Let us do one more problem on this, on type 2 only. If I write integral tan inverse 3x minus x cube by 1 minus 3x square into dx. So whenever I write a problem in indefinite or definite integrals, the meaning is whenever they are defined, means denominator is not equal to 0. Okay, under this condition only we are doing problems. From inverse trigonometric functions, this is the formula of 3 tan inverse x. This and this are same, its formula is this one from inverse trigonometric functions. I'll keep 3 aside because in integrals we have a formula of separating constants. You can keep constant outside and write tan inverse x dx. What I said, whenever inverse trigonometric function occurs singly, you have to take one as second function. So take one as second function. Now this has become first function and this is second function. Use the formula first function into integral 1 dx means x minus integral of derivative of tan inverse x is 1 by 1 plus x square into integral of 1 dx means x dx. So here I have x tan inverse x minus integral of x by 1 plus x square dx. So here which formula will work out? Here f dash x by root f of x. So by looking at this question, you have to come to its relative formula. Its derivative is 2x, but 2 is not there. So make it 2 and divide by 2. And its relative formula is f dash x by f of x dx. Formula is ln mod f of x plus c. So here what I do is I multiply by 2 and divide by 2. So this has become f dash x by f of x by using this formula. Okay, I used that formula. Now answer is x tan inverse x minus 1 by 2 into. This is ln mod 1 plus x square plus c. That is the answer. So I'll give you some problems to practice. You practice these problems. Integral cot inverse x dx, integral secant inverse x dx. Yeah, as I said, in this integration by parts, three models are there, three types are there. Let us see the third type. I write type 3. Type 3 in integration by parts. Here, integration by parts when we use more than once. So in this type, what type of problems we see? In this type, when by parts can be used more than once. More than once. When we use by parts more than once. Or I can say applied, can be applied. Okay. A most familiar question, integral e to the power of ax cos bx plus c dx will come under this category. One exponential function and the other trigonometric function, or e power ax into sine bx plus c. Generally these questions occur in board exams, you can observe, in objective exams as also. Now see how to solve these type of problems. And exactly this question is there. I take this function as I take this integral as I. Now, according to Eilert formula, which function must be given priority? I is inverse Eilert. So in this inverse is there? No. After that logarithm, is logarithm there? No. Algebraic? No. Trigonometry? Yes, trigonometry function is there. So in Eilert formula, among these two functions, which function came first? Trigonometric came first. So this must be given priority. This is your first function. And the rest is the second function. Actually, this exponential function comes last in Eilert. Last is e, exponential function. So this is the last priority function. Now let us use formula. I is equal to, what is the first function here? Cos bx plus c. This is your first function. Into integral e power ax. What is integral e power ax dx? It is e power ax by a. Already we have learnt this in the basic formula itself. So I integrate this and write it here. So integral of second function is e power ax by a minus integral of derivative of cos minus sine ax plus b into again derivative of ax plus b is a. So first function into integral of second function minus integral of derivative of first function into again integral of second function means this one only. E power ax by a. Okay. Here we have bx plus c. Here I wrote ax plus b. It is bx plus c. So again the derivative of bx plus c is b. Right. This is equal to e power ax by a into cos bx plus c minus of minus plus, here you pick out constant parts, b by a is constant, can be kept outside the integral. Now write sin bx plus c into e power ax dx. Again, clearly we have two functions here, sine function and exponential function. Again, take this as first function, this as second function. No change here. Nothing can be done to this because no derivative, no integration. And remember, this total value is I, e power ax by a cos bx plus c plus b by a into. Now I start integrating this by using by parts. First function into means sine bx plus c into integral of e power ax by a minus integral of derivative of sine bx plus c is cos bx plus c into derivative of bx plus c b into integral of this one, integral of e power x is e power x by a, e power x by a into dx. Now I simplify this, I split this into two. Now look, I is equal to e power ax by a. There is nothing to do this, we don't change this, cos bx plus c, cos bx plus c. Now if I bring this a outside and write b by a square into integral, integral is not there, into we can write e power ax is there, e power ax into sine bx plus c, into sine bx plus c. Other than this nothing is there, already I kept this a outside and a into a became a square. Now plus into minus, I can bring b by a, one more b by a outside, already one b by a is there, so I can write b square by a square into integral. So what is left still? Cos bx plus c into e power ax. After bringing this b by a outside, we are left with integral cos bx plus c into e power ax dx. Cos bx plus c into e power ax dx is nothing but again our given problem. So again we got the same given problem here that we supposed as I. So this integral of cos bx plus c into e power x dx, total thing can be taken as I. So in this place I am not going to write integral again, I write I. Okay, b by a, if you bring this b by a outside, this b by a and this b by a are becoming b square by a square, and I have to write integral cos bx plus c into e power ax actually, but integral along with integral cos bx plus c into e power ax dx is I. So I am avoiding that. In that place I am putting I. Right? Now, because I is this side, I bring this I this side now. I plus b square by a square into I is, can I take e power ax common? Now look what we have. If I take e power ax common, I have cos of bx plus c by a plus sin bx plus c by a square, and we have one more b here. Right. If you take I common, 1 plus b square by a square, here e power ax into the LCM is a square. Among a and a square, LCM is a square. So we need one a here, cos bx plus c plus a square satisfied. So b sine bx plus c. I of after LCM we have a square plus b square by a square is equal to e power ax upon a square into a cos bx plus c plus b sine bx plus c. We can cancel a squares in denominators on both sides. And we can send a square by b square this side. So our given problem is I. So finally I is equal to, dividing both sides by a square plus b square, we have e power ax by a square plus b square of a cos bx plus c plus b sine bx plus c. So finally integral e power ax into cos bx plus c, answer is e power ax by a square plus b square into a cos bx plus c plus b sine bx plus c, and add one more c, which is constant of integration. This is your final answer. Similarly, we have e power ax into sine bx plus c also. So I don't explain the total thing here, but simply I write its formula. You practice, you do yourself, and you have to get the answer as for e power ax sine bx plus c dx. Again we are going to repeat the same thing, e power x by a square plus b square into, this time this cos and sine will be interchanged. Here we will get sine and here we will get cos with a negative sign in between. A sine bx plus c minus b cos bx plus c plus c. So if you apply the same procedure, if you do similar in the similar process, you can get this. If you observe this carefully, in the answer you have e power ax. So again e power ax came in the answer along with x coefficients, sum of squares. Here x coefficient is a, here x coefficient is b. We have a square plus b square in its denominator, and a sine bx plus c minus b cos bx plus c. In both the formulas we need one sine bx plus c and cos bx plus c. So what we have to put is the important thing here, because when this type of question occurs in objective, proving this much will consume so much of time. So it is always need to remember this. So when cos comes, remember plus comes and start with cos. When sine comes, in between minus will be there and start with sine only. And this is common for both. In that way you try to remember and right answer. I'll give one example. By using the formula, you need to tell the answer. Yeah, here two formulas are there. If e power x into sin x dx is there, then without doing this entire procedure, by using the formula itself, you have to say the answer. If you compare this problem with this, in the place of a we have 1, in the place of b also we have 1, so both a and b are 1. Come on, applying this formula, because this question is related to this formula. So e power x by 1 square plus 1 square, because both a and b are 1, into a means 1 sine, b means 1 minus b means 1 and cos x, b means 1, no constant, plus c. So e power x by 2 into sin x minus cos x plus c is going to be your answer. So in the place of a and b, you check which value they have given, which constant is there. Right. We have a special case in this integration by parts. You see that special case. A special case. Integral e power x into f of x plus f dash x dx is equal to e power x into f of x plus c. So here also one exponential function with one function plus its derivative. Whichever function is here, you have to find its derivative here. If this is the case, then the answer is directly e power x into the function itself plus constant. And see the proof. Proof is quite easy. E power x f of x plus f dash x integral dx. I separate this and write e power x into f of x dx plus e power x into f dash x dx. I separated into two integrals. I don't disturb this. Let us integrate this by taking this as first function and this as second function, because you know that the exponential function is the last function. So I take this as first function. So first function into integral of second function, integral of e power x is e power x only, minus integral of derivative of f of x means f dash x into integral of second function is e power x dx. So this part is finished, plus integral e power x into f dash x dx. If you observe these two, both are same with opposite signs, so they cancel each other. This is the integration constant. So e power x into f of x plus c. From this, similarly, we can write a note on this special case. Similarly, we can prove this one also. You can prove this by the same procedure. I write e power x in the place of minus x, and here if I write f of x minus f dash x dx. If I write f of x minus f dash x dx, then it is minus e power minus x f of x plus c. You can see this also by applying the same procedure. And see some examples on this model. some examples. Integral x into e power x by 1 plus x whole square dx. Whenever an exponential function is there along with some other function, immediately you have to have a thought that whether this is like e power x into f of x plus f dash x, whether we can write it like that or not. You have to suspect. So one exponential function with some other function. That some other function, whether we can write, we can split into f of x plus f dash x form or not. So let us do like that. E power x into x by 1 plus x whole square dx. Integral e power x into, I write 1 by 1 plus x minus 1 by 1 plus x whole square into dx. See, if I do LCM, what is LCM? 1 plus x whole square only. Already 1 plus x is here. So what is required? 1 plus x is required there. Minus 1 is there. If I cancel this two, I am getting x by 1 plus x whole square. Same thing. So this and this are same. This and this are same. So this is like f of x. This is your f dash x. If you differentiate this, you are going to get this one only. Is not? It is like d by dx of 1 by x. What is d by dx of 1 by x? D by dx of 1 by x can be written as x power minus 1. It is minus 1 into x power minus 1 minus 1. So minus 1 by x square. So remember, d by dx of 1 by x is minus 1 by x square. If d by dx of 1 by x square comes without differentiation, you have to remember some derivatives, some standard derivatives. Okay. Again, I can write this as x power minus 2, d by dx of x power minus 2. And if I write its formula, finally we will get this power, whatever the power is there, along with minus you write in the numerator, and you raise this to 1. You add 1 to this power 3, minus 2 by x cube. I hope you understood. When d by dx of 1 by x cube comes, when d by dx of 1 by x cube comes, then what it should be? It should be minus 3 by x power 4. I hope you understood the pattern of differentiation. When 1 by x square, 1 by x cube comes. If it is d by dx of 1 by x power 10, then what it should be? It should be minus 10 by x power 11. So now, in the place of x, if I take 1 plus x, however, this is a constant, so that does not affect your differentiation. So it should be, derivative of 1 by 1 plus x should be minus 1 by 1 plus x whole square only. So we got the same thing. If this is f of x, along with minus, I got f dash x, it's f dash x. So answer is e power x into f of x, no? So e power x into 1 by 1 plus x plus constant of integration. So this is how the special case is useful to solve problems. Let us do one more example. Integral e power x into tan x plus log secant x into dx. Okay, whenever I write this problem, when this is defined, okay, I am not writing its conditions. Whenever defined. You have to suspect whether we can write that is f of x plus f dash x. Which one is f of x and which one is f dash x? No doubt derivative of tan x is not log secant x. So maybe derivative of this one is this. So if I take this as f of x, if I take f of x as log secant x. Now differentiate this. F dash x is 1 by secant x into derivative of secant x tan x. So our f dash x is tan x only. So what is the answer here? E power x into f of x plus c is the answer, no? So e power x is, what is f of x here? Log secant x. So log secant x plus c. So on this model, you can practice some problems. You can practice these simple problems. Integral e power x sin x plus cos x dx. Integral e power x into tan x plus secant square x dx. Integral e power x secant x into 1 plus tan x dx. A little bit bigger, e power x plus 1 by x plus 2 whole square dx. And you can try this also, e power x into 1 minus sin x by 1 minus cos x dx. You can practice these problems. So basing on this, by integration parts, let us see one or two problems which were given in previous mains. Yeah, in one of the previous mains question, this question occurred. Integral 1 plus x minus 1 by x into e power x plus 1 by x into dx. When you know something about this integrations, different concepts, in the exam, your feeling will be, you can't understand how to start actually. Nobody knows. So in that scenario, what you have to do, you have to make a trial and error. You have to start by making a trial and error method, trial and error. Sometimes it gets clicked. Okay, more practice is required. So this problem belongs to that category, right? Even though it is appearing like e power, some function is there with some other function in the brackets, one may think that it is, whether it is e power x into f of x plus f dash x type or not, like that. So here I can solve this in a different manner by not applying that formula. I write e power x plus 1 by x into 1. Okay, 1 into e power x plus 1 by x dx. And for the second part, x minus 1 by x into e power x plus 1 by x as the another integral. See, here I take 1 into e power x plus 1 by x and integrate by taking this as first function and this as second function. Nothing wrong in this. So far, we have done for inverse trigonometric functions, if any inverse trigonometric function singly occurs. I took that function as first function and one as second function. When log x function comes also, log x can be taken as first function and one as second function, and we have done. Here, in this case, I take 1 as first function and this e power x plus 1 by x as second function. Nothing wrong in it. You can make trial and error also by taking first function, second function, by taking 1 as first function, right? But if after differentiation, we have to get the same function, reverse process, no? That also we have to look. If I take like this, yeah, I take this as first function and this as second function. Now first function into e power x plus 1 by x into integral of second function is x minus integral of derivative of e power x plus 1 by x is e power x plus 1 by x only. Again derivative of x plus 1 by x. Derivative of x is 1 and derivative of 1 by x is minus 1 by x square into dx plus, I don't disturb this, I write that as it is, x minus 1 by x into e power x plus 1 by x dx. Yeah, I am successful, both got cancelled. So x into e power x plus 1 by x plus c is the answer. We can do like this also. Take this. So with this I completed this by parts, integration by parts. You go through this video, understand, try to solve as many problems as possible on integration by parts. And after this I made a video on partial fractions. You go through that partial fractions, understand them, practice problems on partial fractions. After that we come to how to integrate functions which are like partial fractions. A fraction comes with different functions in numerator and denominator, and if problem of that type occurs, how to decompose them. How to decompose them we'll learn in partial fractions, and how to integrate them we'll learn again in integrations by using partial fractions. That is also one of the important topics of our integrations. If that part is over, integrating by partial fractions is over, then in the beginning of my starting of the lesson I said original integration comes. Second set of formula will come, and that will play the remaining indefinite integrals, which is actual integrations, right? So after completion of this integration by parts, you go through my partial fractions video, practice some problems, understand different types, for which type, how to do that thing you have to understand. And after that I'll make one more video on integrations for partial fractions, how to integrate partial fractions. A big problem will be given, we have to decompose that into parts, and those parts must be individually integrated, right? Until then,